All right, so the principal work that I've brought to the conference, and some of you might have seen hints of a Lego table outside, so this is part of that. And I would comment that the colleagues before us, the keynote speakers, they talked much about computation and the amount of it we're going to have in the near future. I'm actually trying to fill a gap that is described as acknowledging we have a lot of computational power in society today, and myself and my lab and colleagues are trying to build tools that bring that computational power to society at large. So I think there's a huge amount of work we could be doing more of just in the realm of interfaces and how we bring computation to the problems we solve. Just a shout out to my home institution, MIT Media Lab in Boston, another cold, beautiful place like Vancouver. And the work that this comes from is sort of this realm of interactive visualization that I conduct with a number of researchers in the School of Engineering at the MIT Media Lab, and with our collaborators in Japan and the like. I should also give a shout out to the people who make this work possible, not just myself. I actually have my collaborator Nina Lutz here at the conference helping out, answering questions. She's a very active researcher adopting these tools for her own research. So I'll start with this phrase, form follows function. This is actually something I was drilled into us actually when I was in architecture school. I'm not trained as a technologist per se, but more of an architecture and planner. And the idea behind this is that, at least when I was taught it, was that architecture should ultimately have a form or a look to it that emerges from the purpose that it's designed for. It's kind of a modernist philosophy. And then as I've evolved into a technologist, I think it's still very relevant that the technology we build should mirror the need in society. And I think that this presentation is a story about a tool we made to meet a specific need we found in the lab, rather than us trying to cram a tool into some needs that we hope people might need. So this story started in planning school, where we're fortunate at MIT that despite it having a reputation as a technology institution, it has a strong humanist tradition when it comes to teaching architecture and planning. It's very socially engaging. We do collaborative design exercises where problem solving is done with communities and people. And I actually had the benefit of learning that from an early age. The benefits of this process is it's social, it's analog, often hands-on, adaptive, where you can change on the fly during the workshop, and it's usually very open. Out in the open, people can see transparently what's going on. Simultaneously, there's this exciting new world, at the time for me, and I think it's still exciting, applying computational methods, parameterization, to processes like planning. And this, on the other hand, even though it's very exciting to me as a scientist learning these tools, it tends to be a very solo endeavor. We're using more digital and precise methods, which are exciting, but it's often a closed process where you find yourself working till midnight, maybe in your room, building some neat models, and then hopefully showing them to some people, but it's a very, sometimes, lonely experience. An example of that parametric modeling process, this is an island in Shanghai that we're doing an exercise on. It's a condemned industrial island that they want to make into a mixed-use facility. And to usually design these proposals for density mixed use, you simplify the problem to the historic buildings, the parks, the infrastructure, and then with parameterization, we can do things like rasterize that information into its key components and start to define it digitally as far as parks, mobility hubs, centers of attractors and defectors and rivers and the like. And then when you bring that into a computational environment, you can do things like program your density as a function of these amenities. So here's a proposal that has certain coefficients, attractors, levels set for different efficiencies based on maybe value judgments, maybe empirical evidence. But you can adjust those parameters a bit and get a completely different solution. And that's the excitement that drew me to parameterization. But the problem with these methods is that, again, I'm experiencing this excitement from my computer console. how do I bring this to stakeholders like this? Oops. Sorry, this appears to be double skipping, so I might just go to my laptop. So this is an example of a research exercise where we invited participants who are not planners, engineers, biologists, et cetera, to urban planning exercises. And they didn't have the language and the tools that we had as trained architects and planners, but they had the interest in designing cities together. So we built this medium that they could use to talk to each other. And that medium principally is Lego bricks. And we had this way of not only having this fun, playful, tangible medium, but we also, in a way, quantized it, at least in a kind of quasi-quantitative way. Like we said, that these types of Lego units of these colors represent these land use types in this much area. And we gave people, these groups, kits where they could essentially, these 4 groups are designing their own cities using the same standard kit with some constraints, but for the most part, trying to carry out their own vision of what a city could be. Now, that was a very promising exercise because we saw such divergence in the solutions, but the problem was we have all this rich user input data that qualitatively we know all these cities are different and would behave differently, but how do we digitize all that user input in a way that can actually give us that information so we can do further computation, further analysis? So the results of that question are actually outside of this room, so I hope you'll stop by and see it. We call it the tactile matrix. It is essentially an illuminated, machine-readable system of colored tagged objects and projection mapping that does, as you build, or essentially as you build these cities or whatever object on the table, it's scanned in real time, brought into a mathematical model, computations are done, and it's reprojected, augmenting that model for you. So there's an example where you can see that these essentially Lego objects, these don't have RFIDs embedded in them. So the novelty of the system is that we can scan such a large quantity of objects that are cheap to build, low tech, and we're not putting batteries and sensors in every single one, and so we can actually scale this quite large and arbitrarily. And we're preserving, because it's on a tabletop, that aspect of collaborative prototyping. So I hope to see lots of people standing around outside, maybe multiple people around the table, don't be shy, and actually maybe arguing about what goes where. And that's sort of what we like to see with these interfaces. And of course, for me as a computational researcher, I'm excited to take math models and put them into practice. So in this example, you're seeing a walkability model, sort of like walkscore.com, but put into practice in real time. As a user is placing office buildings in this residential environment, that walk score in the area is going up because you're providing more amenities to walk to and from if you're living there. The system as a whole, as a platform at least, incorporates a lot of different technologies that we kind of put together. So we're resting on the shoulders of these giants who've provided open source platforms and tools. Computer vision techniques, OpenCV, were adapted and rewritten to allow us to scan the Lego tag. So it's sort of like a naive version of a QR code, actually. And we have 3D game engines that we're borrowing for these, so the same things you use to play games. And projection mapping, like if you've ever been to a performance where you see on large buildings these displays and projection maps, we're actually using the same thing at a smaller scale. And of course, we had to design our own tabletop that has a clear acrylic tops that allow us to combine the computer vision and the projection mapping together. And of course, we have some space specifications that go hand in hand with these prototypes and tools. Outside, notice we have a nice controlled environment, not too many glaring bright lights. Perhaps we're working on algorithms right now that actually eliminate the need for computer vision at all for an electronic grid. So more and more of these can be deployed, we hope, in any type of environment. This is an example of a setup I did recently in the UK with GlaxoSmithKline. They're developing a manufacturing system, intervention simulation system over there. So at this point, now that you kind of got an idea for the tool and how it came up into the world, there's a few stories about how that tool has since caught the eye of some new case studies, and we've ventured out and explored new ways it could be applied. in the research. And as a technologist, I'm actually very skeptical and hesitant to say that my tool should be used for lots of other applications, because I think there's a right tool for every problem. But in this case, for the most part, we've had people approach us and say, we like that system, we think it could be used for that. And we're like, huh, okay, let's try it. And we've actually had some very interesting results come up out of that sort of collaboration. So one of the first was with Saudi Arabia, where the planning authority wanted us to design a prototype system for planning land use in a brownfield site. So we have this square kilometer area right here in Riyadh that's being redesigned for walkability. And we designed this first version of the system to allow people to move land use around, residential, non-residential, and it output 3 key parameters: daylighting, walkability, and energy consumption as a function of location. And this is a video from that workshop where all the while different groups of people are coming in giving us data about their peace movements and their decisions over time. And we're actually recording these graphs of people's movements so that we can do some post-analysis and see which parts of the board have more attention given to them, so we can actually start not just enabling people to work together, but start collecting data on how people work. This is actually my Seoul, Canada example right now. This is something we did for Toronto, where we built a version that allowed people to place residential and office buildings in a dense environment and see how that might affect the traffic balance at a relatively neighborhood scale. So you can see as you place only commercial use here, you see traffic balance kind of getting out of whack. You need lots of parking. But if you were to theoretically provide now residential in equal measure, you can start to see this balancing effect actually, where if you create trips within the city rather than in and out of the city, you actually have a lighter load on your roads, theoretically. This is a recent deployment in Singapore. We actually have this example out on the table in addition to another. The premise here is we're building a pedestrian accessibility model with real amenities loaded into the system from the GIS data. And if you place new amenity interventions, it'll actually, based on their existing sidewalk networks, show you the paths that people might take to and from those amenities. This was a fun one because it was probably one of the biggest ones I ever made. And sometimes you just got to see how big you can make these. This was actually in our own backyard, Kendall Square in Cambridge. We built a giant model with our lab inside of it. But most importantly, this area in the middle is a parking lot that's being developed for office use. And at the time, there was no solid plan, and they were looking for input for the people's preferences and designs. And we thought, well, rather than a traditional planning process, what if we had people come in, design some things on the table? They can put retail, housing, office, cafes, build it up. And meanwhile, the system's giving them feedback on what's breaking the law or what's feasible or not. So they're kind of being checked along the way. They're being computationally assisted. Some people would call that AI. I would just say it's whatever. The computer's telling them they're right or wrong, or illegal or not illegal. And then they can print out PDF of what they did and email it to the developers. So that was, academically, I was collecting data and very interested in people and the way they made decisions. But I think community-wise, there's a large potential for us to automate and the process of having public feedback put into systems and development projects and large systems infrastructure projects. This is an example where we actually, probably our smallest scale, we were building literally bus stations and showing people how different implementations of a bus station on their street might affect their neighborhood. In particular, it's called bus rapid transit. It's like a variant of a normal bus system that runs a little more efficiently because it's operated more like a subway. And we're showing, most people don't understand the difference, so we're showing, building a system to teach them the subtle differences of that. Hoppen City University is a collaboration that I really love because it's an example where we gave other people a tool and a kind of a community and a new use emerged out of it that we couldn't have predicted otherwise. Essentially, I packed some suitcases full of Lego, went over to Germany for a week. We had a lot of fun. We built a neighborhood case study. They actually brought tools and mediums. They built their own foam model, which is more traditional, but we integrated into the physical model. And after a week of building hardware, we actually did some software tutorials. This is programmed largely in open source Java code. It uses processing if anybody's ever used that. I highly recommend it. And so within about a week and a half, we had them mostly independent. They not only had one of these tools, but they could hack it. And we said, go nuts, you can do whatever you want. And they built maps of traffic noise. So traffic noise was something more important in Germany than I had ever encountered in other cities. They also really still like doing hand sketches, so they just had a little applet that let them import hand sketches onto the model and overlaying that on the digital information. They presented at this conference, the Solutions Conference in Hamburg, Germany, where they were the only planning school with all these tech people, which I thought was fairly novel. But after I left, the mayor literally went to their school and told them they have this refugee crisis brewing. And the mayor asked them, can you please readapt that tool for our needs? And they actually built this whole project, and you can go check it out. It's called Finding Places, where they used a version of the system, the tactile matrix, for allocating, bringing community members in and exploring where they could allocate refugees in their city. Due to time, I'm going to kind of breeze through a couple of these, but this is an example in China where we actually put into practice into a consulting environment the system, and this is just showing the development team over there that's growing that I'm working with to try and bring this into reality. And the last I saw it, it's this huge system spreading throughout China, which is pretty fascinating. And they actually added all these new software and features and plugins to it. And then this is another demo outside, so I won't talk much about it because you can go see it. With Walmart, we were doing logistics planning and placing warehouses instead of buildings on the table. So like we are seeing distribution areas populated in real time. Oh, and then finally, last slide. This is work we've done with the GSK recently for pharmaceutical manufacturing. And those pieces represent units of production capacity you can build on the model. All right, well, thank you much. I don't know if I have time for questions, but I'd love to hear them, but you can probably just hound me down. Thank you.